Good morning, everyone. I'm Seet Wan Yin from Group 9 Goldrich Consultancy. This is the minor video presentation for the Integrated Design Project 1 Erosion and Sediment Control Plan, which is under the supervision of Prof. Madhya TS Dr. Tarmizi. Erosion is the process when the top layer of the soil surface is detached from the soil and worn away. Sedimentation is the term used for the deposition process. Sedimentation may pertain to objects of various sizes, ranging from large rocks in flowing water to suspension of dust and pollen particles. Once the sediment has entered a waterway, it is very difficult and expensive to remove. Hence, reduction and control of sedimentation is very important. First of all, we have to carry out the rainfall estimation for the designing of urban drainage and stormwater management project. So in our project, we have to determine first the average recurrence interval, where we adopt the minimum ARI of 2 years. And we have to determine the time of concentration using the formula of T0 plus TD, where the T0 and TD value can be calculated using the formula as shown in the diagram, while the N values, which is the Horton roughness value, can be obtained from the table. And for our project, we assume that the land surface is bare soil, hence the N obtained is 0.0275. And next, we can calculate the rainfall intensity using the formula in the boxes, where the constant applied for this formula is obtained from the MASMA table according to our catchment, where we use the JPS Johor Bahru as our station. Then the calculation proceeds with the estimation of peak discharge, and this can be done by using the formula as shown in the boxes, where the runoff coefficient used for this project is 0.5 for bare soil as recommended in the MASMA table. So these are the peak follow for every zone in our project. Next, we have to design a temporary drainage to redirect or channel the runoff to a silt trap. Manning's equation is used to estimate the flow rate in the temporary drainage, where in this formula, the Manning's coefficient is obtained from MASMA table, and in our project, 0.02 is used as our Manning's roughness. Trapezoidal drainage is chosen because it has a moderate slope and higher water resistance capacity compared to a triangular channel of the same depth. And this is the formula used to determine the bottom channel width, the area, and the hydraulic radius of the trapezoidal drainage. And these are the criteria for the temporary drainage design, where the flow velocity has to be less than 2 meters per second and the float number has to be less than 1. And this is the temporary drainage design for our project. Then we have to proceed with the soil loss estimation, and this can be done by using the universal soil loss equation as shown in the diagram. As Johor is the blue zone, which falls in the range of 12,500 to 15,000, so for the evaluation purposes, the higher limit R factor is applied in our project, which is 15,000. And this is the K factor given by lecturers. And the C factor can be obtained from the MASMA table according to different conditions. While the P factor used in the project is 1 for bare soil. And this is the soil loss estimation at every zone for my group. Next, sedimentation yield estimation. Sediment yield is the amount of sediment calculated at the drainage point's end from the prescribed region, and it can be estimated using the modified universal soil loss equation as shown in the boxes. This is the result, where the total sediment yield for every zone. And next, we have to design a sedimentation basin, because it is a temporary pond with appropriate control structure used on construction sites to capture the eroded or disturbed soil that is washed off during or after rainstorms, and it is important in reducing the water contamination. And these are the tables used in the design consideration and criteria for the sediment pacing. And in our project, we are applying 2 types of sediment control. First, the silt fence. It is a temporary sediment control device which consists of filter fabric stretched across and attached to the supporting posts backed by a wire fence for support. It is installed on the site before the soil disturbance begins, and it is placed downslope from the disturbance area. It should be inspected and maintained on a regular basis, especially after the rainfall event, because it is easily damaged. The second sediment control is by using wash bay. It is usually placed at the main entrance of construction site to prevent the sediment being trapped onto the public roads and to control dust, pollution, and wind. The pond construction material is normally using concrete or other suitable non-erodible material. The overflows and the stormwater runoff from the wash bay should be directed to a sediment trail. So these are the final design drawing for our Escp, where there are 3 sediment basins and 2 wash bay, which is located at the main entrance. And last but not least, the silt fence, which is located at the downslope area of the project area. We have come across with 2 problems, where the first one is when calculating the soil loss estimation, K factor cannot be determined as we did not have the opportunity to do the soil test. So the soil data and the K factor is provided by doctor. And the second problem is the LS factor is wrongly determined as we refer to the wrong layout for uncontrolled and controlled condition. Hence, LS factor for the uncontrolled and controlled condition is calculated based on the proposed level given by earthwork department after the research. And I think that's all for the minor video presentation for the sedimentation and erosion control plan. Thank you. Good morning everyone, I'm Seet Wan Yin from Group 9 Gold Ridge Consultancy. This is the minor video presentation for Integrated Design Project 1 under Water Reticulation Department. I'm under the supervision of Dr. Erwan Hafizi. So for the introduction, water reticulation is a process of designing a network of pumps, pipes and water storage to distribute water to the proposed area. We have to make sure the supply of treated water is at sufficient pressure and quantity to the consumers. Also, a water tank will be built based on the water demand in this project to ensure that every customer has an adequate supply of water with sufficient pressure and quantity, as well as to store enough water for a specific area in the event that the water supply is temporarily shut off. So for the pipe network system, a combination of closed-loop pipe networks are employed. This is to ensure the consumer will still receive water in the event that any pipelines are closed for maintenance. So the Hardy cross is used to calculate the residual pressure head using Bernoulli's equation, and the network is fully solved when the pipe network has 0 for the loop. Please make sure that the pipe diameter should be adjusted if the residual pressure head is insufficient. And this is the diagram for a closed-loop pipe network. We are required to figure out the precise pipe diameter that will provide a sufficient residual pressure head at each node. For our group, we agreed to use the HDP as the pipe material, and this is the diagram. And while the coefficient is 120, it can be get from the table B7 Hazen-Williams coefficient. The diameter we are using is 100, 150, and 200 mm. HDP is chosen because it's tough and durable, corrosion and chemical resistant, highly flexible, lightweight, and it has a long life. So for the water demand, we have to calculate it based on 1-day storage and the type of facility. Because from the plan layout, there are different users, and we can choose the water demand based on the tabulation given by SPAN. The average water demand in pipe approaching each tank is calculated using the total storage volume in the tank per day. After the average flow is calculated, we have to find the peak flow by multiplying the average flow with peak flow factor. And the peak flow factor used for this project is 2.5 according to the SPAN hydraulic requirements. And this is the result of our peak flow rate. Our project e-panel is used to analyze the simple distribution network and determine the velocity, flow rate, and pressure head needed with Hardy cross methodology, as it facilitates the evaluation of various management strategies for enhancing water quality throughout a system. So this is the standard procedure where we have to draw the network representation of our distribution system, and we have to edit the properties and describe how the system is operated. Then we must select the alternative for analysis and run it to view the result. So the head losses is calculated using Hazen-Williams formula, and please make sure that the value should be less than 2 m per 1000 m for gravity flow. Pipe velocity is an area average property that is independent of the pipe's cross-sectional flow distribution, and it can be calculated using this formula. Please make sure the velocity is within the range of 0.3 to 2 according to the SPAN requirement. So from our result, there are several velocity that did not meet the standards. In order to mitigate the low velocity, we have to add appropriate anti-corrosion and anti-scale additive to the pipe system. And we also have to inject suitable emulsifier into liquid hydrocarbon water system to stop the phase separation from happening at slow speed. While for the result, we can see that all head losses meet the standard. For the residual pressure head, we have to make sure it is more than 7.5 meter and less than 30 meter. From the analysis, all pressure head meets the standard. And this is the dimension of our water tank by ePlanet, which it can fulfill the consumer requirement. This is the layout of our pipeline, and this is the schematic diagram generated by ePlanet. So throughout the project, we meet two problems, which is the velocity does not meet the requirement. Hence, we have to reduce the pipe diameter. And next, the size we use for the HDPE pipes is not available for most suppliers. Hence, we have to customize the size based on the required diameter pipe. And I think that's all for the minor video presentation for water reticulation. Thank you. Good morning everyone, I'm Seet Wan Yin from Group 9, Go-Reach Consultancy. This is the minor video presentation for the costing and estimating, where my group is under the supervision of TS Dr. Eeydzah. Costing and estimating is conducted early in the project lifetime. It provides support and information to aid in the planning process and effective workforce distribution for optimal project flow, reducing any waste or cost overruns. It is a process of projecting the total cost and other resources required to accomplish a project within a specific scope, and these are the examples of costs involved. First of all, we have to determine the type of equipment used during the construction. Then we have to consider the labor cost, whether local or foreigner is employed. This is because according to the Human Resource Ministry, foreign workers in Malaysia is growing as they are employed at a cheaper cost compared to the local labor. Second factor that affects the labor cost is the skill level. This is because the skills of labor and efficiency are the critical factors in project performance, where you can see that the skilled labor will have a higher pay compared to semi-skilled labor. Second consideration is the cost of material, where there are different charges of transportation and discharge if we are using different machinery. And the last consideration is the cost of equipment. This is because different field and hiring rate will affect the total cost of the project. And the objective of this project is to reduce 30% of the total cost. And these are the bill of quantity for our project before and after the cost reduction. And we successfully reduced 29.47% of the total cost, which is approximately to 30%. And in our project, the cost estimation is carried out for the removal of trees, excavate topsoil, cut to proposed level, transport from cut to fill, fill to proposed level, compaction, disposal of excessive cut, and grading. This is the comparison of the cost for removing trees. We can see that the cost reduction is done by reducing the unit of equipment and by increasing the duration for the equipment. And this is the comparison of each activity cost before and after reduction. Other than the method I mentioned just now, actually we can reduce the total volume of cut and fill. This can be achieved by suggesting a new proposed level that will reduce the excavation and compaction work. And it can further reduce the cost of transporting additional soil from off-site to the on-site area. Secondly, we can suggest a machine with the same capability but at lower cost by comparing the rate and capacity of the machine and choosing the best option. And lastly, we can replace some of the skilled workers with semi-skilled workers. This is because skilled workers requires critical thinking to make a judgment, while semi-skilled worker focuses more on physical work, equipment, and machine handling. So these are the problems we face during the project. First, difficulty in finding machines or equipment that have complete specification for cost estimation purposes. Hence, we have to carry out multiple reference from the internet and other sources that have complete specification regarding the selected tool, especially regarding the machine rental cost. Next, percentage of estimated cost did not reach the requirement. Hence, re-estimate is carried out, especially in the cost of renting machines and labor wages by sticking to the official reference. And I think that's all for the minor presentation video for costing and estimating. Thank you.